Wrong. I'm gonna write an equation for the pay rate. My pay rate was $5 an hour to start with, plus $1 a year times years worked. Okay, the rate is $1 per hour information. And this week, well, last week, last week was done, but I will tell you that this this week, I'm probably going to be really burning the midnight oil. And we're twice as many hours, double the number of hours I work. I will remind you, and there is an equation which tells you your dollars per hour is equal to your income, let me say, your paycheck divided by your hours. Okay, so I'm gonna tell you, this week I plan to put in the midnight oil and actually get the grading done. Who am I kidding? I'm not gonna have it done by Thursday. I'm gonna get the grading done just to start. Actually, I did do it last test. I did. I was a good boy. I got your grading done now. I'm gonna tell you, this week I'm putting in the hours, and I'm probably gonna do twice as many hours of work. I ask you, how does my rate change? By what factor? Google question A. By what factor does my pay rate change when my hours double? I've given you some information, and I wish to see if you can tell how ASU's appreciation, monetary appreciation anyway, changes if I work twice as many hours this week. And ASU's paycheck, I've just given you the professor, the assistant teaching professor formula. $5 plus number of years, dollars per hour. You can turn to your neighbor too. Turn to each other, talk to each other, check each other. How's my paycheck? No. How's my how does my rate change? The dollars per hour change if my hours double. The hours double. I'll write it down. And when I say, how does this change? I am always asking the ratio. What is my new dollars per hour divided by my old dollars per hour? I currently make $15 an hour, by the way. Because people are making the exact same mistake in a different context. And I'm hoping that if I give a context that people have some experience with, it'll make some more sense. Am I? Yeah, I think I am. So what can you deduce?
Oh, wait, no, it's just.
What can I deduce if I work more hours? Dun, dun, dun. Good, good.
Oh.
You got it.
No, I want to do it. Okay, so it's experience. Okay, so yeah,
And I'm telling you, this is my 15th year, 10th year, so I make $15 an hour. $15 an hour. No. No, they don't pay. They just don't detonate the explosive colors on it.
Wait, no, yeah.
Hey, Google question B. How many years have I worked when I work twice as many hours? How many years have I worked? Google question B. How many years have I worked this week? If I, again, this is my 10th year. And I'm saying if I have worked twice as many hours, how does the number of years work? If I work twice as many hours this week. There is a point to this, by the way. I'm not just humble bragging that I make money. Oh, again, I started work in 2016 at ASU. Same year I finished my PhD. Started in 2016. This is my 10th year. And I'm wondering, how does that change when I work twice as hard? No, they just don't detonate the explosive callers on my family. You can actually look up every ASU employee's salary. It's public info,
We're getting.
I guess. I don't know. Let me encourage you to think about this. Do I have a DeLorean? No, I drive a trashy actually Prius this year. I drive a trashy old car. Don't zoom me into the future just because I'm putting in the hours. I get more gray hairs. It doesn't make me travel into the future any faster than 1 second per each second. So the number of years doesn't change. What can you conclude about my rate? What is my hourly rate now? If my number of years doesn't change, does my rate change? It stays the same. You have to think, what did I tell you? The very first thing I told you about ASU salary, wages, they're based on the number of years worked. I started at $5 an hour. Now I'm making $15 an hour. Okay, so there be a formula saying paycheck over hours, and more than half of you told me that doubling hours halves my rate. But my rate isn't controlled by my hours. My rate is controlled by my years. What the fork, Tucker? But there's an equation that says hours and rate are connected. What does change? Google question C. I work more hours. What changes? Again, I double the number of hours I work. What can you conclude changes? Yes, you already know that the hours change. What does the hours changing cause to change? If you go into your job and work longer, I mean, honestly, from what I've seen of the economy and entry-level jobs, that's impossible because you're already working 24 hours, but okay, my friends, if you work longer hours, you make more money. Your paycheck increases if you work more hours. Paycheck changes, not rate. Your dollars per hour is based on, I don't know what capitalism makes your guys's paycheck improve or not as the brutal system decrees must not change. If you work more hours, you get more paycheck, not more rate. There was a study done. There were 100 couples were surveyed And all told, there were about 250 kids in those families with kids. 250, 100 what? 100 families, and all told, there were about 250 kids. In all 100 families, yeah. You're looking at a whole bunch of sampling of this particular group in America. There's about 250 kids per 100 families. Okay, now I'm going to ask you, if you look at twice as many people, there's birth rate change. Google question D, I'm going to ask you about, if you look at twice as many families, how does the kids per family change? Let's write down an equation here. Kids per family D. Not inserting a penis joke here. D, kids per family equals number of kids divided by families. If I tell you that 250 kids happened when 100 families were surveyed. Oh, this isn't right. This isn't the birth rate. Oh, it hurts to say something so wrong, but I don't know the right word. Fecundity? Whatever. I'm going to ask you, if you survey twice as many families, how many kids per family do you have? I'm going to increase the number of families that I survey. And I ask you, how prolific are those families? How much sex they having? And again, I'm asking about the rate here. How does the birth rate, I guess the sex rate change? I guess it would be the birth rate, would be per family. Okay, let me ask you, the more people you ask, does that change how much they're having sex? No, no. Just asking more people doesn't change how much sex is going on here, which again, in this generation is about 0. Making up BS numbers to illustrate a point here. Or so I've, read. The number of families increasing means the number of kids will increase. Just because you have an equation here doesn't mean that this variable affects that variable. You have to use reasoning and logic to deduce how does this change that. Let's talk some physics here. I have a capacitor. I have a capacitor. I have a pineapple. I will remind you that the capacitance of a parallel plate capacitor is area epsilon over distance between the plates, and capacitance is defined as charge per volt. Google question E, if I double the voltage on a particular capacitor, I'm going to give you guys a capacitor. How does Q change? I'm going to go out. I'm going to buy each and every one of you Merry Christmas. Here's a 1 microfarad capacitor. I'm going to buy you a capacitor. And on the side, it's printed 1 microfarad, 1 UF. Hand it to you. It's your capacitor now. And I'm going to ask you if V becomes twice as great. Please also think about the examples that we've just been doing and try to deduce a, well, that's my question. Does the capacitance of a capacitor depend on this or what? I'm handing you a capacitor. It's yours. It's fixed. It says 1 UF on the side of it. It's your capacitor. You're not changing the capacitors. You're dealing with the same capacitor. You're not swapping it out for a different guy. You're not modifying it. How much charge changes? Okay, question F. How does capacitance change? How does capacitance change? Do you guys remember when I gave you a 9-volt battery in the last test? And then asked if you do such and such to a resistor, how does the voltage change? How did the voltage change? Did the 9-volt become a D cell, a 1.5-volt battery? No, why not? Because that's what the battery does. I give you a 1 microfarad capacitor. You're not cutting it open. I said nothing about changing it. I said nothing about replacing it with a different sucker. The charge changes. The capacitance doesn't. Unless I am specifically talking about you replace this capacitor with one with half its capacitance. Unless I specifically say you take the plates and double the distance between them. If these numbers no changey, this number no changey. Capacitance does not change. So what can you deduce? If you have the same number for capacitance, for God's sake, you have the same number of capacitance, and I want this fraction to stay the same. If a fraction doesn't change, how do I keep the fraction the same? If I make this top twice as big, what do I have to do to the bottom to keep it equal to something? If charge per volt is 5, and then charge changes and it's still equal to 5, what happened to voltage? It has to be changing by the same ratio in order to keep the fraction constant. Just because you see a formula, you have to reason about it. Guess what? What's physics going on here? What is in the real world going on here? Like I was just saying, I work twice as hard, my paycheck goes up, not my pay rate. Don't age me prematurely. Don't age me prematurely. I've worked 10 years and I don't suddenly have worked 25 to double my pay rate just because I work harder. Just feels like I've worked 25 years. So, when you have an equation, you have to know what causes what to change. Please do write this down and think about this. Resistance, capacitance, inductance. We'll get to that, hopefully. Battery voltage. These are properties of resistors, capacitors, inductors, and batteries, respectively. They depend on the properties of the object, not the properties of the electricity. Next unit, after the break, after the midterm, we're going to talk about wave. We're going to talk about oscillations. And you're going to discover that if you're on a swing, if you're a swinger, you're on a swing, swinging back and forth, you can swing fat, big swings, go high up, you can swing low swing, go low down. There's an equation which tells how fast you go. The time it takes to go all the way back and forth. And those are calculatable based on you and the swing property. The swing frequency depends on the swinger and the swing. I will then ask you, how does doubling the height change the frequency? And the correct answer on the final exam will be it doesn't. The swing is dependent on, I'm sorry, the oscillation frequency, we will see, is dependent on the oscillator, the thing itself, not the motion of the thing. Last semester, I doubled the mass of an object. How does that change its acceleration? If I freely drop it, it doesn't. There is a formula that says you could solve acceleration equals force over mass. If force becomes, if mass becomes twice as great, force becomes twice as great. Think about what affects what and the relationship between things. Don't just assume that everything else is constant. Please.
I was gonna ask, can you like show kind of what a question, like how it would look like on the midterm?
Sure.
Using the stuff that you just used?
Here's a question on the midterm. If I double the voltage on a particular capacitor, how does the charge change? Except I would write out the word voltage and charge. This is entirely possible to be asked. There are a couple of other examples on the midterm, or the voltage example, voltage on the resistor formula from last one. You can take that exact question, the last question on midterm one, say capacitor instead of resistor, and it's the same question. How does the voltage change? It doesn't. It's fixed by the battery. Okay, now, I want you to, let me test to see if that made any sense. I've got a capacitor, I give you a capacitor, and now I squish the fork out of it. I'm gonna make the distance between the plates half as great because I'm so small. Grr, look at these muscles. I'm gonna make the capacitor half as big. Okay, the sucker's attached to a battery. How does the area change as a result of squishing the capacitor? And how does the charge change as a result of squishing the capacitor? Again, I am going to halve D. I am going to attach it to a battery. What happens to the plate area? And what happens to the charge? What letters are we on? G, plate area. H, charge. A, Q. Yeah? Do you see what I'm asking? I'm trying to squeeze it onto one page. It's probably a sin. Teacher sin. Questions about what I'm asking? Did you hear the question? Squish the capacitor. How does that change its area? How does that change its charge? It's up to a battery. Please answer the question given, by the way. I've got several people talking to me about something I didn't ask. I halve the distance. I'm asking you if I halve the distance between the plates, what does that do to area? What does that do to charge? It is hooked up to a battery. And talk to each other. Explain not just the what, but the how, the why.
Essentially what you're doing now is finding both of these. So you're saying that your active both sides. So four side distance is half, which means that the area is lost. And if you help this.
No. Flip. Tell this much. But here's a point that I saw more than half of the theory class failing this after getting multiple times. I wanted to try it. No, we'll absolutely look at it.
That's all. Yeah. Yeah, because now seeing a lot of things teaching. Yes. We have the. To decrease always. It should double, but then You have the.
What did I just say about the nature of batteries? How you change a battery voltage, or if you can. And what changes the capacitance of a capacitor, if possible? Does this affect that? If I drive on the freeway for 2 hours, does that slow me down? Does my velocity change because my time increases? Let's make this like even more hopefully visualizable. I've been dealing with capacitors for 25 years. The capacitor plates are your hands. You put some metal dust on your hands or whatever, make your hands metallic, you turn into Iron Man. Your hands are now the capacitor plate. Here, I've made a capacitor. I do this. Oh. Okay. Here's my capacitor. Oh. That's what I have done. I've connected my hands to a battery. What happens? How does that affect area? How does that affect charge?
Well, you know. Yeah. So I mean. Exactly.
I'm gonna give it like 1 more minute and then we're gonna move on to a different topic. Again, for Google question H, please read the question asked, what happens to charge? I'm not asking about voltage.
And so you have three things, right? So it's efficiency or something or something, right? So if you do one thing, the double the other, the third thing has to say the same thing. One of them has to say. Okay, we're out of time for doing this idea that I'm banging on. We'll be hitting this. I just said there'll be a question on the final about swing. And what happens if you're a swinger that goes up higher? You know, if that changes this time, yes. Okay, do I need a bigger glove? Did my glove size just double? No, no. Just because I move my hands forward or back doesn't mean the area of my hands changed. Yes, there's an equation that has both A and D in it. But like, seriously, does changing this make my hands bigger? Maybe Donald Trump wants it to be so, but no, you can't wave your hands and suddenly make your hands bigger. Area is a property of your physical hand. The distance between them does not control the size of your glove. What does happen if I make D half as big? What happens to a fraction who's downstairs gets smaller? Fraction goes up. If I have something divided into quarters, and now I divide it into halves, I've got more of something. If I have 5 quarter slices, 5 quarter pizzas, no pizza and a quarter, and then I have 5 half pizzas. Whoa, 2.5 pizzas. Now that's talking about them. So if D, did I say doubles or halves? I said half. If D gets half as great, capacitance increases. Remember what I said before. How do you change a capacitor? Capacitance, you change the capacitor. It's not impossible. I've just got to specifically say it, and I did specifically say it.
Now, if capacitance does what? Capacitance gets bigger. What do you know about batteries? What does that do to voltages? Stays the same. If the left side gets bigger by a factor of 2, what happens to charge? It gets bigger by a factor of 2. Do not memorize. Charge never changes. Do not memorize. Capacitance never changes. Do not memorize. This doubles. You have to think, have a mental model of what these things are and their meaning. And this is not encouraging. And this is something that we're going to continue to work on. But please, when you go home, I would like you to make up examples for yourself. And if you're not sure, make up examples for yourself, for your neighbor, for your classmates, probably not just your neighbors. And if it doesn't start to click, email me. Hell, email me anyway. Email me your example and your proposal. And oh my God, God willing, I'll be buried under a stack of emails. Ask me. Ask Sahyu too. He knows this stuff. I'm making a point here. And it's a point that we very badly need. When you see an equation, what I'm seeing is about half of the class is looking at an equation and turning off any connection with what that equation means. Equations are not God. You're God of the equations. Math serves us. We do not serve math. Okay, now, all that said, another problem that I was encountering with the 3 o'clock class is using calculators to plug in numbers. And I would like to practice that because it is very important. Half the questions involve numbers. You must be able to number in your calculations. We have an equation that says voltage equals voltage of a point charge is KQ on R squared. And I'm going to ask you, where do you have to stand to get 9 volts from a proton? Where do you have to stand such that, relative to a proton, such that the voltage you feel at that location is 9? Yeah? German pun? I will remind you that K is 9 times 10 to the 9. I will remind you that that fundamental charge, absolute value of electron charge, is 1.6 10 to the negative 19. Moreover, you are not allowed to use your calculators this time. Google question I. Do it by hand. With brain. Write your final expression. Whoa! No squared for voltage. That was a test on you and you failed. Should have corrected. And then J. So write your final expression and then algebraically simplify. Hint, you can do this. You don't need a calculator here. Do it with calculator and make sure that you get the same result for both. Both are important skills. I want you to find where, oh, for God's sake, I can't write. Where is V equal to 9 volts? If you have a proton, not a pineapple, not a pen, but a proton, what location is voltage 9? Use the formula, use the numbers, and plug in. I have chosen things intentionally. You can do this. Good. Good, good. First steps are encouraging. Take your time. If you're not sure, you can simplify the hell out of this and it works. Now do your calculator, make sure you're able to do the same thing. I also encourage you, reflect on the order of magnitude of your answers. Molecular processes in the real world are on the order of magnitude of volts of energy per charge. Voltage is a reasonable scale for processes that happen in chemistry. Your answers should be roughly on par with real molecular dimensions, not billions of light years away. Reflect on orders of magnitude and you can rule out wrongo answers. And if you do guide each other, please help each other explain why, not just what the answer is. Please put these in I and J, my dudes. Give you some butter?
No, you get it.
And you get an A for giving me an A.
Oh, yeah. You can see the one thing. One, you go ahead every. There you go. You just take it. Shout out.
I wish I was gonna be on the.
Percent. Yeah.
Yeah.
Okay, we're at 80% right, but we've got like 30 people not answering. I hypothesize that scientific notation is confusing. I would like to try a different, also the quantities involving voltage and distance and electric field and such are giving you nightmares. Let me propose an alternate. Let me tell you that the equation y equals a divided by x plus b. And I'm going to give you a equals 3, b equals 2, y equals 5, find x. No, I don't know whether the numbers are going to work out pretty. Wait, I can make the numbers work out pretty? I can work it out in my head? Nah, I just worked it out. Oh, I want to make them pretty. Here, y is 1. Let's see if taking away algebraic notation, the scientific notation, and putting in familiar math letters. I encourage you to check your answer. If you plug in your value of x, does the equation hold? Okay, and I'm gonna say that this should be enough time to do, and I've got 16 people here. And I've got 15, sorry, 13 I can subtract. Correct those. 13 out of 16. Oh, for God's sake. Is again an 80%. Okay. Okay. Here's how to solve this algebraic equation. If I multiply both sides by x plus b, I clear the fraction on the right side. Now I would like to get rid of y. I want x alone. So to get rid of a multiplying y, I divide both sides by y. If I want to get rid of the added factor b, I can subtract b from both sides. And then I can plug in numbers, a, 3, divided by y, 1, minus b, 2. 3 over 1, last I checked, the rumor on the street is that it is equal to 3. 2, last I checked, is equal to 2. Correct answer for x is x equals 1. Now let's put it in scientific notation. See if this is where you're dying. Okay, I'm going to say x equals 3 times 10 to the 8th. Y equals 5 times 10 to the minus 2. And z equals, oh God, what in this formula does it? I'll keep it simple, but sure. I will give you that y equals 1. Nope, I'll make it simpler. This is actually a lie. We got 86% with small numbers. Can we do big numbers? Can we do scientific notation? If not, I will insert a module on scientific notation. You may use your calculator here. And give me your answer in scientific notation. Let me see if you can put it in back, preferably. Yeah, let's see. guys were in ninth grade in COVID. You guys were in ninth grade in COVID. You guys had a general science year during COVID lockdown, didn't you? Who had COVID? Who had a general science year in during the pandemic lockdowns? Ooh, my goddesses, why did I not think of that? No wonder scientific notation is a struggle. You didn't learn it. You weren't taught, well, you learned it during COVID. That's why it's weak. Okay, I feel really stupid for not having realized this. Well, I know that, but that's why some of these foundational skills, this isn't hard. Once you're taught it, not in a tiny screen. Obviously, the people who are skipping class, I'm not talking to them, but y'all who are here, we're going to do a module, a unit on this, and I think that you will all be much happier in your lives. Because scientific notation is slaying you. Okay, okay. Let's see, we have done, what have we done? We have made big realizations that we should have realized during the pandemic that this would happen now. We have talked about how this affects that. We have talked about doubling and halving in that same process. I wonder if I should just tell science. No, I can include a couple, but I'm not going to make every problem include big and small numbers. I will give you guys 3 Coulomb charges, which is ridiculous. It is not realistic, the scale of things that will give you. But there we go. Okay, one more thing before I let you go. I want you guys to pick using the correct, identify what is the reasonable equation to pick in a couple of different circumstances. So this, you do not need to give me a number. I just want you to identify, is this a foundational, let's say 3 choices. You have 3 choices: definition, point charge, capacitor. The following situations will describe some things, and I want you to identify which of the genres we're talking about. What equation for which section of your equation sheet do we have? Is that fair? I think this is something that's been requested. And again, you do not need to give me equation. I just want you to say one of 3 things: definition, what is it, point charge, or capacitor. Okay, Google question M. Can you identify the following? A thundercloud has a voltage between the ground of 1.5 gigavolt. The ground is about 1 kilometer below it. And there is a area of the cloud of about 10,000 square meters. I want you to identify what genre of equation would let you find the electric field inside between the cloud and the ground. What genre of formulas would let you find, given the distance, the area, the voltage, what could you use to find, which formula, which genre would you use to find the electric field? And I should maybe write this sucker out. Do not tell me numbers, please. We will do that second. What did I just say? What topic even? Again, what equation links these terms that I've given you? I may give you information that is not strictly required. You do not necessarily have all of these variables in. I will tell you that I have given you every variable you need to solve for electric field. I'm going to have you solve it in a minute. But first, I want you to identify what general topic is involved here. And let's go ahead and put N. What is the equation? What equation would you use to find E? And O, find E. Oh, I found E, it's right there. No, no. Evaluate, give me a number. Give me your number, baby. Again, you should be able to plug in the numbers given into your equation and give me a number. So in Google question N, if your equation has terms that have nothing given here, you should rethink your life choices. I'm getting a whole bunch of people telling me true equations that don't apply here and cannot possibly be it because you don't have the number. You're not given that quantity. You can't solve for that quantity with what's given. You would have to have additional other information. You guys are giving me variables you don't have and telling me you can use that to solve the equation. Hint, if it involves variables you don't know and aren't given other than E, it's not the right equation.
Really? Thank you for your service. Okay. No, you deserve the $5 an hour.
Actually, it's a zeroth here, so he gets infinite. Wait, no, crap. Never mind. I can't. Divide. Okay, let's rule some crap out here. Why is KQ divided by R squared not the right equation to use here? How can you rule out KQ on R squared? KQ on R squared is a true statement for point charges that involves Q since you're not given. Big fat hint. You don't have Q. The second thing is, am I talking about a object is located at a point, what is the field nearby it? I've got a cloud that I've described, it's an enormous surface area. A cloud over the ground, two big surfaces facing each other. Does that mean that this is a capacitor formula? So this is the capacitor field equation. Q over A epsilon naught. Damn, there's a Q in there. No, you can't use that then. Well, what's the third choice? What is the central equation linking voltage and electric field? One of the core four that I said are definitional equations, and I'm not going to ask you where equals force times distance. Voltage equals electric field on existence. Then, so if I solve for electric field is volts per meter, 1.5 mega million newtons per coulomb, 1.5 times 6 newtons per coulomb, or volts per meter equivalent. Let me give another question. Which context would allow you to find the electric field at the location of an electron? Yeah, question first.
What topic?
Given the scenario described and the information provided, what would your strategy be? What section of your notes would you even be looking for? If I tell you these things, how can you get to finding electric field? If you know your definition, your core central always true equations, volts equals field times distance. If you know that that exists as a statement and you see, oh, I've got volts, I've got distance, I want field, that equation is, if you know it exists, you can look it up. But you got to know, oh, hey, that's a definition, that's a core, that's a central, you look to that part of your note card. And for what it's worth, again, you look at the point charge, you look at the capacitor formulas, they involve a variable reliability. Tell me the equation. If I tell you that we did this one. Find the electric field experienced by an electron due to its proton in hydrogen atom. Find the electric field due to the proton at the location of an electron. What genre of formula am I even using? What equation would I use to find it and then solve it? And I'll give you numbers. Charge on the proton. Yeah, this makes more sense to say. Good. Bad. Good. Bad. Hey, by the way, if you don't know what I'm talking about, point charge, the defining equations that are always true versus the specific to point charge versus the specific to capacitors, that was yester class. Right? It was last Wednesday, right? I mean, before break, right? We were starting the review process and I said, here are all the equations you could need and their category, their topic. Yeah, that was yester class. S, find the capacitance of a proton and an electron. What would you say? What would you put? What would your answer be if I asked you for the capacitance in the situation? And please talk softly about this one. Again, plugging in the numbers is the breaking factor. Oof. Nope, 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 and nope. It's that, isn't it, by the way, when you're done? People who are done. It's that you were never actually taught scientific notation in a class that wasn't on Zoom, right? That's gotta be. When that was after pandemic.
My class specifically learned scientific notation during high school chemistry,
Yeah.
but that was due for me because I was junior year of high school.
When were you junior high school? It doesn't tell me if it was lockdown.
2022, so close to the pandemic.
Okay, but just after, true. Okay, but that's the point again. Did you learn it in person or no?
Yeah, I think
Okay.
complete years for police officers. By which I've already approved as COVID was the later part of 8th grade, like March after 8th grade, and then all of 9th grade. But then 10th grade, at least for Clyde Town, we were back in person. We also never for a red tap that is only fast. So I also do that. I did. I think the reason I can't do so
Sleep?
Yeah,
Yeah, is that too?
I believe they stick in my class.
Okay, I'm still gonna say, if only 6 people after 5 minutes can do this, you're not solid on it. It's not real for you. It hasn't clicked. Just what do you think about my hypothesis? Question T here real fast. I want to go back to S in a second. Let's word it this way. Have you learned scientific notation during a time when you actually could be expected to, like, for reals, learn it? Did you learn, have you been taught, have you actually been taught scientific notation? That's what I'm going to ask. Question T, have you been taught scientific notation for realsies? And how does that correlate with the other? I'm so smart. It only took me 3 years to realize this, but... Yep, half the class. Okay, so we will do units on what the heck these numbers mean and how to manipulate them. The plugging in numbers is still not where I want it to be, but I'm going to cheat. I'm going to make things 1 meter away with a capacitance of 3 farads is not realistic. I like to keep numbers realistic-ish when possible. So I want you to get a sense of an order of magnitude. Is this what does this quantity even mean? But screw it for many of them. The correct answers, by the way, were point charge, and the equation that applies is KQ on R squared. S, what is the capacitance of 2-point charges? Anybody? Shout it out. What's the capacitance 2 points? No. Google question S for realsies. What is the capacitance of 2 points? How could you find the capacitance of 2 points? $14 years ago. Okay. Okay, Google question S. If I asked you, what is the capacitance of 2-point charges, what would you say? Turn to each other and describe what is a capacitor in 5 words. And then answer the question. What's a capacitor? Or, 6 words, whatever. What is it? How do you make it? How have I, another hint, how have I always sketched capacitors? Whenever we've sketched capacitors or talked about why capacitors behave they do, I've included little diagrams, like not every class, but every time that we have sketched a capacitor or you've seen it in the homework, what's it look like? Hint, hint, hint. Google question S, what's the capacitance between 2-point charges? Yeah, I know you didn't pay attention during the pandemic. It's not, I mean, okay, some of that's on you, but no, everyone didn't pay attention during the pandemic.
There's a guy in my Zoom meeting, so I did like a PNG of some guy in an office chair, he looked like that profile or something.
I mean, yeah. It's not a great week to learn. Okay, we have 2 minutes left, so I'm just gonna say, what's a capacitor? 2 parallel plates separated by a vacuum, separated by an insulator. Is 2 points parallel plates? Now, as it happens, there is such thing as the capacitance between 2 parallel points, but it's not part of this class. Every time I've talked about capacitors, I've been saying the capacitance of a pair of plates. I've been sketching 2 little rectangles opposite each other. I've been describing it as the parallel plate capacitance. You don't know the formula. You should know what you don't know as well. This is called not part of the course, and if Tucker puts it on the test, it's raise your hand and shout at him. What's a capacitor? Hell, maybe I should include that as a can you identify if I sketch the sucker that I've done a million times? Can you identify the schematic symbol of a resistor? No, maybe I'll put that on file. What is this symbol? And I draw a resistor. Okay, anyway, please, I wouldn't ask you S this time, but maybe we're gonna touch on know what you know and know what you don't know more over the course of the last third of the class. I love each and every one of you. Please study and please ask questions. Bye.
Right.